इस लेक्चर में हम एक बहुत ही इम्पोर्टेंट कंसेप्ट डिस्कस करने वाले हैं और ये एक तरह का शॉर्ट मेथड होगा फॉर अ न्यूमरस क्वेश्चंस विच कैन बी आस्क्ड इन जेईई मेंस एग्ज़ाम और नीट एग्ज़ाम। हम क्या देखेंगे कि जितने पुली बेस्ड क्वेश्चंस हैं रोटेशनल मोशन चैप्टर के, जिसमें पुली का इनर्शिया गिवन होता है, उसको विद इन 30 सेकेंड्स कैसे सॉल्व करें। इसमें हम डेरिवेशन करने के बाद जेईई मेंस के 2 क्वेश्चन भी सॉल्व करेंगे एज एन एग्जाम्पल। इसका ऑलरेडी हम एक शॉर्ट अपलोड कर चुके हैं यूजिंग द एनर्जी कंजर्वेशन प्रिंसिपल। इसको हम एक अलग तरीके से सॉल्व करेंगे इन दिस लेक्चर। वी विल फर्दर सी 3 sets of example problems in order to understand our derived shortcut. Alright, तो ये मेथड है क्या। सबसे पहले हम डिस्कस करते हैं कि हाउ our journey of physics started. In kinematics, what we have seen, the acceleration is simply given by the F net upon the mass of the particle. This we have seen in the kinematics. Further, when we move to the laws of motion, having pulley and 2 blocks of masses hanging on it, what we have seen, the acceleration can be written as the net unbalanced force upon total mass of blocks. This we have seen in laws of motion chapter. In laws of motion, the examiner particularly specify the pulley is massless. This is because examiner wants you to ignore the moment of inertia of the pulley. That's why it is written the pulley is massless. Because if the pulley does not have any mass, the moment of inertia of a pulley, considering it a disk, can be written as half mr square. If it is massless, there will be no inertia of the pulley. That's why while calculating the acceleration, you are taking the net unbalanced force like this, m1 minus m2 into g upon the total mass. This is valid up till laws of motion chapter. When we enter into the rotational motion chapter, what we find, the pulley now have some mass. The pulley has some mass, hence it will have some inertia, and that inertia will be resisting in the acceleration of the blocks. Alright, so how to solve this kind of problem in a short way? So first of all, what we will do, we will derive the formula and then try to understand it in a simple way. Then we can apply that as a short method to the similar problems. We will see each and everything. So let's delete all this. Now concentrate on this question. Let's suppose the m1 is heavier than the m2, hence the acceleration will be in the direction of m1. So what equation we can write from the forces marked for the m1 block? We can write m1g minus t1 equal to m1 into a. Alright, for m2 block, what we can write, this is accelerating in upward direction, hence t2 is more. We can write t2 minus m2g equal to m2a. This is the second equation. Now for the pulley is rotating like this. means the torque produced by the T1 is more than the torque produced by the T2. Hence, for pulley, we can write T1 into R minus T2 into R is equal to net torque equal to moment of inertia of the pulley multiplied by the angular acceleration. Alright, so this can further be simplified and written like this: A upon R. Taking this R common, we can write T1 minus T2 equal to I A upon R square. This is our third equation. So we need to solve out these equation number 1, 2 and 3 to calculate the formula for acceleration. So let's do that in a quick way. What we will do, we will find T1 and put here. So simply we can write m1g minus Ia by R square minus T2 equal to m1a. This is fourth equation. Writing second equation below this, and such that the T2 is written just below the T2 of equation 4. Alright, this is equation 5. This is nothing but actually equation 2 only. Now adding these two above equations, we can write m1 minus m2g minus Ia by R square minus T2 plus T2 will cancel out, and this will become m1 plus m2 into a. Taking this term to the right hand side and solving for a, we get acceleration equal to m1 minus m2 into g upon m1 plus m2 plus I by R square. So this is the acceleration formula considering the moment of inertia of the disc. If you remember what we have discussed earlier in laws of motion, only this part was coming out, means this is the extra term which we need to consider in case of rotational motion. Hence, in short, we can define acceleration as unbalanced force upon translational mass plus rotational mass. Now I am saying I by R square as rotational mass because the dimensions of I by R square term is nothing but of mass, because we know from units and dimension chapter only quantities having the same dimensions can be added. So if this is mass, this term is also having dimension of mass. So that's why I am writing rotational mass. And how we have achieved this? We already know the I the moment of inertia of any body depends on the two parameters, the mass of that body and the radius square. So if we divide moment of inertia by the r square, then it becomes representation of mass. Alright, I hope you are getting things till now. So this formula will be acting as a short method for us. We will be using this very frequently for the single pulley system. And there is one thing you need to note here. The note is this thing is applicable only for those devices in which all the connected bodies have same acceleration. This you need to take care. Alright, this you need to take care. Hence, if this pulley system is given, then it is not applicable. Alright, where it is applicable? Only for those devices in which all the connected devices have same acceleration magnitude. Okay, so here we can see the acceleration of mass m1 and m2 will be same, hence we can apply. Here there is only one body, hence the same concept can be applied here. Here again there is only single body, here also we can apply the concept. Here also we have this m1 acceleration same as m2 acceleration, hence we can apply here also. Here also the acceleration of m2 will be same of acceleration of m1, hence we can apply here also. Again this is a single body, hence we can apply the above concept here also. So let's quickly solve these questions. In this question, mass of pulley and radius are given 4 kg and 10 centimeter. Mass of this block is also given 2 kg. What is asked? Tension in the cord is asked. So let this be the tension. Tension here will be nothing but m into g minus a, where a is nothing but the downward acceleration of the block. Due to downward acceleration of the block, a pseudo force will be acting upward on the block. That's why we have written mg minus a. So if we know the value of a, we can calculate the tension, and the acceleration can be written from the above formula that we have already discussed. That is, unbalanced force here is nothing but 2 into 10 upon translational mass. Translation mass is only of this block, hence 2 plus rotational mass. Here moment of inertia is not given, directly mass of pulley is given. Alright, so and the radius given. The pulley is nothing but act like a disc. If this is acts like a disc, hence the moment of inertia is half mr square. So So this is I. The mass is given 4 kg, radius is given 0.1. Calculating this, we get 2r square. Let it be like this, 2r square. So what we need to do here is, we need to write I by r square. I is 2r square. So 20 upon 2 plus 2r square upon r square equal to 20 upon 4 equal to 5 meter per second square. Hence acceleration comes out to be 5 meter per second square. Now to calculate the tension, we can write mass of the block, acceleration due to gravity is 10 minus 5, 2 into 5 equal to 10 Newton. 10 Newton is the answer. Let's move to second question. In this, solid cylinder is suspended symmetrically through two massless strings. The distance from the initial rest point, the cylinder should be unbinding the strings to achieve a speed of 4 meter per second. In simple words, ये solid cylinder कितना height down जा चुका होगा when the velocity is reached 4 meter per second. So what we will do, we will use our short method to calculate the acceleration of the solid cylinder. Net unbalanced force will be the mass of the solid cylinder multiplied by the acceleration due to gravity upon translation mass will be the mass of the solid cylinder, and the rotational mass will be the I upon r square. For solid cylinder, I is given by half m r square. So I by r square is nothing but m by 2. Putting this term here, we get mg upon m plus m by 2. Solving this, we get acceleration equal to 2g by 3. This is the acceleration we get. Since this acceleration is constant, means we can use the equations of motion of uniformly accelerated bodies. So here we know the acceleration, we know the final velocity, we also know the initial velocity, and we need to find the h. Hence we will use the third equation of uniformly accelerated motion. What we can write, v square equal to u square plus 2ah. V is given 4 square, 0 square plus 2 into 2g by 3 into h. From here we calculate h as 16 by 4 into 3 by g. So solving this, we get 12 by g, 12 by 10 equal to 1.2 meter. In centimeter, we have to answer, hence the answer is 120 centimeter. The same question we have solved using the energy conservation principle, and it has been uploaded in the shorts section. You can watch that also. So let's move to the next example. Here two pulleys are given, but what we need to take care, the acceleration of all the devices involved must be same. Here also the acceleration of this m1 block and m2 block will be same. Hence we can directly write the acceleration formula for the given system. That will be, acceleration will be net unbalanced force, that we can write as m1 minus m2 into g. Alright. Upon translation mass is of the blocks, that is m1 plus m2. Rotational mass will be contributed by both the pulleys. So if I1 is the moment of inertia of pulley 1, then its rotational mass can be written as I1 by R1 square. The rotational mass contributed by the second pulley can be written as I2 by R2 square. Hence, this is the acceleration formula for the given system. The question is solved. Now, let's move to the next question. In this, mass m1 slides without friction on the horizontal surface. The frictionless pulley is in the form of a cylinder of mass m and radius r, and string turns the pulley without slipping. Find the acceleration of each mass and tension in each part of the string. So again, the acceleration of m2 block and m1 block are same. That's why we can use our short method. That acceleration can be simply written here. Total unbalanced force is m2 into g. There is no unbalance, there is no negative force produced by the m1 block because it is resting on a horizontal surface. Hence the unbalanced force in this system is only m2 into g. Upon translation mass will be of m1 and m2, and the rotational mass will be contributed by the pulley, that we can write as I upon r square. Since pulley behaves like a solid cylinder, hence moment of inertia of pulley can be written as half m into r square. So we can use the data and find out the acceleration. And in order to calculate the tension in each part of the string, let T1 be this tension and T2 be this tension. T1 can be written as, for the block M1, T1 is nothing but M1 into A. Alright, putting the acceleration value, you can find the T1 expression. And T2 can be written as M2 into G minus A. This is because as the acceleration is downwards, a pseudo force will be acting upwards. So the T2 is nothing but M2 into G minus A. You can go into the free body diagram and find out the same expression. Like this is mg, this is pseudo force, this is pseudo force, and the tension. So what we can write, T plus m2a equal to m2g, T equal to m2g minus m2a, hence m2 into g minus a. Same thing. So T2 can be find out like this one. Now moving to the next question. Here a string is wrapped around a solid cylinder and then the end of the string is held stationary. While the cylinder is released from rest, find the acceleration of the cylinder and tension in the string. Here also there is only a single body. We can apply our short method to calculate the acceleration. The net unbalanced force is contributed only by the solid cylinder, that is mg. Translational mass of the solid cylinder is m, and rotational mass can be written as I by I r square. Here I is the moment of inertia of the solid cylinder. For solid cylinder, about the given axis of rotation, I is given by half m r square, implies I by r square is m by 2. Putting this I by r value here, we get mg upon m plus m by 2. Solving this, we get acceleration equal to 2g by 3. So to calculate the tension in the string, what we can write, mass into g minus a, because for this solid cylinder mg mass is acting downward and a pseudo force of mass into acceleration will be acting upward because the acceleration is downwards. Acceleration is downwards, hence pseudo force will be in the opposite direction. Tension is also acting upwards. So from here we can write T plus Ma equal to mg, hence T equal to mg minus Ma equal to m into g minus a. So putting the value of acceleration which we have already found, g minus 2g by 3 equal to m into g by 3 is the answer for the tension. So I hope you like this lecture. Please consider subscribing for more content.